In this video, we're going to talk about how to find all the solutions to a trig equation. And the trig equation we're going to look at is 2 cosine theta plus square root of 2 is equal to 0. So again, our strategy, we're not given an interval this time, so we want all of the solutions, and we're going to talk about how to write the infinite number of solutions in a pretty cool way using good notation. But the general strategy is still going to remain the same. What we want to do is we want to isolate the trig term right there, the cosine theta, and kind of get it equal by itself on one side of the equal sign, and then use the unit circle as a starting point, and then we'll talk about what to do from there. So in order to get the cosine theta by itself, the first thing we're going to do is subtract the square root of 2 from both sides. And that's going to leave us with 2 cosine theta on the left-hand side, and that's going to be equal to the negative square root of 2. And then to get the cosine theta completely by itself, we're going to divide both sides by 2, the left and the right-hand side, and that's going to give us cosine theta is equal to negative square root of 2 over 2. And so now that we've isolated the cosine theta, again, keep in mind that cosine theta on the unit circle is just going to be the x value. And so we're going to go around here looking at all of our points, the ordered pairs, and we're going to circle all of the places where we have an x value that's equal to the negative square root of 2 over 2. And starting at 0 and moving around, the first x value equaling negative square root of 2 over 2 is going to happen at 3 pi over 4. And the second one and the last one, at least between 0 and 2 pi, is going to happen at 5 pi over 4. So our x values are negative square root of 2 over 2. So that's why I circled those. So that gives us two different solutions for theta. So we know that theta could be equal to 3 pi over 4, but it also is going to be equal to 5 pi over 4. And if all we wanted were the solutions between 0 and 2 pi, then we would stop right there. Those would be our solutions. But we need to think a little bit more about this problem because we don't just want the solutions between 0 and 2 pi. We want all of the solutions. And there are really going to be an infinite number of places where the x value on the unit circle, if we continue going around the unit circle, is going to be where it's going to be equal to negative square root of 2 over 2. It's going to happen an infinite number of times. So let's talk about how to represent that. Now we're going to use the 3 pi over 4 and the 5 pi over 4 as a starting point. But now let's kind of think conceptually about what would happen if we added 2 pi to each of these. So keep in mind that 2 pi, if we added that to, we'll say 3 pi over 4, that's going to take us all the way around the unit circle, and we're going to end up right back where we started. Except for this time it's going to be 2 pi over 4, or 3 pi over 4 plus 2 pi, whatever that's equal to. So if we did that over and over again, we could continue adding 2 pi over and over to each of these, and every time we're going to get a new angle, but it's going to end in the exact same spot. So these are going to be coterminal angles. And like I said, we could do that an infinite number of times. And then when we get tired of that, we could subtract 2 pi, and that would take us back, and continue subtracting 2 pi to continually get answers. And we could do that for 3 pi over 4, and we could also do that for 5 pi over 4 over and over and over again. And so the idea here is that we can add or subtract 2 pi. That's going to be a whole rotation around the unit circle. We'll get something else, a coterminal angle that's going to have the same x value. In other words, is going to satisfy this equation that we began with. And we can do that for any value of k that we want to. Now k is going to be an element of the integers. And that right there, that kind of z script looking thing right there, k an element of z, that just means that k is an integer. So we're talking about things like negative 3, negative 2, negative 1, 0, 1, 2, 3, so forth and so on. So all of the whole numbers, positive and negative, and 0. And if you think about that, just putting any value of k in there that you want to, 3, negative 100, that's going to add that many 2 pi's or subtract that many 2 pi's from the original starting place. And so that's going to give us another answer that satisfies the equation. Now we're going to do the exact same thing for the 5 pi over 4 because we can do the same thing from that starting point. We can add 2 pi, but we can add it k times, again, where k is an element of the integers. And so this is going to represent our solution set. And since k can be any number, any integer, it's an infinite number of solutions. And this is the way that we represent it. So if you want to choose something besides k, sometimes people will choose n, then that's completely okay. You could just say n instead of k everywhere that I've got a k. But the idea here is this is going to represent all of the solutions to the trig equation. 2 cosine theta plus the square root of 2 is equal to 0.